start the unit on transformation. So this is Unit 2. So today is Unit 2, Day 1. If you want to go back and watch the video, it will be labeled Geometry, Unit 2, Day 1. And so what we're going to talk about today is transformation. Now, a transformation is basically when you take an object and you move it somewhere. Okay? So the change that happens to an object, if you just take it, whether it's a triangle, quadrilateral, rhombus, whatever the figure is, if you take it and you move it somewhere, that is called a transformation. Okay? So let's talk some terms. We're going to fill in some blanks here. A transformation is an operation that maps an original figure called the pre-image. So the original is called a pre-image onto a new figure called the image. So pre-image is what you have to start with. Image is what you have as a result after the transformation takes place. Okay? Y'all ever play with Transformers? My little boys love Transformers. When I hear transformation, I think about Transformers. I know that's off topic, but I like it. All right. A transformation can change three things. It can change the size of an object. It can change the position. Or it can change the orientation. So if it changes the size, that means it makes it bigger or smaller. If it changes the position, that means it just slides it over one place to another. And orientation is kind of like the way it's pointing or facing. Okay? Changes its kind of its direction. So today we're going to start with talking about reflections. So reflections are the only transformation we're going to focus on today. Okay? There are 4 major transformations. I'm going to go ahead and tell you what all of them are. You might want to put this somewhere. Where is my eraser? I have one eraser and it's never where I want it to be. Okay, so this is just some side information. There are going to be 4 transformations that we will talk about over the next 3 days. They are reflections, translations, rotations, and dilations. Okay? There's 4 major transformations that we're going to see in this unit. Reflections, translations, rotations, and dilations. So today we're going to talk about reflections. All right. Y'all know a reflection kind of like a mirror image, right? Right? So if I take a selfie, I know that's a funny example. If I take a selfie with my phone, right, and I give a thumbs up in my selfie, and it looks like that I do it with my left hand, but when I look at my picture, the thumbs up will be on the right. Right? Right? Okay, so that's a reflection. We know what mirrors and selfie mode and your camera and stuff like that does, right? Okay, so yeah, my 5-year-old was asking, but I'm moving this hand. Why is it showing this hand over here? So I had to explain reflections to my 5-year-old the other day, and that was kind of interesting. He was really confused. All right, so reflection is a flip. When you flip something over a line, that is called the line of reflection. Okay? So when we have a reflection of an object, it is flipped over a line. Okay? There's an invisible line that you see when you look in a mirror or you look in selfie mode in your camera. Okay? Each point of the image and the pre-image are the same distance from the line of reflection. So, for example, this picture that I give you right here, this A over here is the same distance from this vertical line as this A prime is over here. Something else, the little apostrophes that you see on the letter, we call that prime. So this is point A, and this is point A prime. So the originals just have the letters, the new ones have the primes. The apostrophe, we call it prime. Okay? So, same thing. B is the same distance from the line of reflection as B prime is. C is the same distance from the line of reflection as C prime is. Okay? You got the same distance in both directions. All right. There are a lot of possible lines of reflections. Two common ones are the x-axis and the y-axis. And also vertical and horizontal lines. Do y'all remember from Algebra 1 I told you guys to memorize that x equals a number is a certain type of line and y equals a number is another kind of line? Y'all remember it? So, well, x equals a number is what? Do y'all remember? Vertical or horizontal? A vertical line. Very good. Write it down here if you don't remember it. And y equals a number is a horizontal line. So we need to know that again for today. And diagonal lines, some common ones are y equals x, which is your parent linear function, or y equals negative x, which has a negative slope. Now, this stuff will all make sense, hopefully, after we see some examples. So we're not going to work every example on page 1. We're just going to do a couple so that at least one of each type. Okay? So that's my plan, is to give an example of each type of thing we're going to see. All right. So let's look at problem number 1. Triangle ABC with vertices, negative 4, 2, B is 4, 7, and C is 5, 1. And we want to reflect it in the x-axis. Now, the first thing we're always going to have to do is graph the original image. Okay? So I cannot see my x and y axis, so I'm going to bold those. Y'all can see it better on your paper, I think, than I can mine. All right. So the first thing we want to do is graph the original. Uh-oh, my battery's low, it says. That's what it is. Sorry. So I'm going to highlight or darken my x and y axis, and I want you to graph and label your points for A, B, and C. So A is the point, negative 4, 2, so left 4, up 2. Label it. Okay? And then positive 4, 7. And these are like, they go from negative 8 to positive 8 in all directions. So you know 7 is going to be 1 down if it goes to 8, right? So to me, it's easy to kind of memorize that. So there's B, and C is at 5, 1. Okay, so there's the original pre-image triangle. I should have used a ruler. So connect the points, make a triangle. So something you're going to learn about these transformations is they're not mathematically that difficult. It just takes a while to grasp. Okay? And some of us have to let go of our OCD. All right? So it says to reflect it in the x-axis. Well, this is the x-axis, isn't it? So that is the line of reflection. I'm going to go over that with a highlighter or something. So that is my line of reflection. Okay? So that means when I graph the point A prime, I'm going to be the same distance from that x-axis as A is. So A is how many spaces away from that horizontal line? 2. So to graph A prime, I'm going to go 2 down. 2 above the x-axis, so I'm going to go 2 below it. Okay? So 1, 2, 1, 2. A prime. So when you label those, make sure you put the little apostrophe because the new ones are the primes. All right? B is how many spaces above the x-axis. So I'm going to go 7 straight down in the other direction. So B prime will be right here. C is how many spaces from the x-axis? 1. So just go 1 below it. And grab C prime. And then draw your figure. So for a reflection, if it's a horizontal line or a vertical line, basically all you have to do is count the same amount of spaces. And then all we have to do is write down the ordered pairs from our points we graphed. Or there's a shortcut. Y'all know the shortcut is? What is it? Flip the y's. So if you're reflecting in the x-axis, you can multiply the y values by -1. If you change the sign of your y values, that will get you your new points. Don't change the x's because the x values are the same, right? If you multiply the y values by -1, you will get your new points. So some people like to do the points and then go back and graph. Does that make sense? And some people, if you forget the shortcut though, you can graph and then go back and do your ordered pairs. So you can do these 2 ways. Does that make sense? So A prime, what's the coordinates for A prime then? Get the x, change the y sign. So the original y was 2, we'll change it to negative. Does that make sense? So for B prime, we're keeping 4 for x, and what's y going to be? -7. For C prime, we keep C, the x is 5, and the y is going to be -1. So like I said, if you're reflecting in the x-axis, you can do this part first and then graph, or you can count spaces and then write ordered pairs. Okay? Let's go across to number 2, please. This time we have a rectangle, PQRS with the vertices, and they're given, and they want us to reflect this one in the y-axis. So first thing we need to do is graph that original rectangle. So everybody graph that PQRS first, please. Gotta make my axis where I can see it. Make sure you label your points, because if not, it is no use to you. It's a rectangle. It's tilted sideways, but it's still a rectangle. All right, this time we're reflecting it how? Over the y-axis. So I'm going to do the shortcut instead of counting this time, if that's okay with y'all. You can't see my highlighting, but I'm trying to highlight the y-axis. I don't know what it's doing, but it's not letting me highlight it. Maybe if I go over it green or something. You can see that. Barely. All right. So you can count spaces. So P prime would be right there. Q prime would be 2 spaces over. What do you think is the shortcut for reflecting in the y? Right. You multiply your x's by -1. So your y's are going to stay the same if you're reflecting in the y-axis. And then you're going to multiply your x's by -1. So P prime would be what ordered pair? -1, keep the 2. What would Q prime be? -2, 5. What would R prime be? negative 8, 3, and S prime would be negative 7, 0. And then you need to go back and graph it. So like I said, I don't care if you do count your spaces and then write your ordered pairs, or if you write your ordered pairs and then graph, but you got to do both. Does that make sense? I like to do both and kind of check. So there's P prime. Just make sure that the new one has the apostrophes. P prime. 3. Star prime. And then 0 is S prime. All right, so it looks like the blue one. I flipped it over that line, and there goes my red one. Does that make sense? So any questions about reflecting in an X or a Y axis? Pretty easy, isn't it? And like I said, those have a shortcut. All right, we're going to skip the next two examples and turn to page 2, please, in your packet. Let's do some vertical and horizontal lines. So I'm going to go to problem number 5, please. All right. All right. So I have a triangle, and I want to reflect it in the line x equals 4. Now, what kind of line is x equals 4? It's a vertical line. Okay. So first, let's graph the original triangle, please. Does the triangle look like mine? Kind of skinny looking. All right, when you have that triangle drawn, look up here at me so I know that we're in the same place. Yeah, mine's ugly. All right. So we already said that x equals 4 is a vertical line. Well, where is that vertical line? It crosses the x-axis at what number? 4. So you just count off over to 4. 1, 2, 3, 4, and you're going to draw a vertical line right here. Okay? 1, 2, 3, 4. So you need to memorize, if you don't already have it memorized from Algebra 1, that x equals number is a vertical line. So mine's green, maybe you can see it. Now on these, you do have to count the spaces. Okay? So if it's in the x-axis or a y-axis, we just had to change the signs on the x's or y's, right? But if it's any other vertical line or horizontal line, you actually have to count the spaces. All right? So L prime will be 1 space over. J prime will be 3 spaces over. And K prime will be 2. And then you're just going to have to count up your ordered pairs. So that's going to be 6. And just keep in mind it's negative 8 to positive 8 in all directions. So that's going to be negative 8. Positive. Ah, did the wrong one. But look, do it and see what you notice. Sorry, I'm getting my letters confused. J prime is going to be 7, negative 1, right? And L prime is going to be 5, negative 2. It's positive 8, 3, right? Where am I doing? What am I doing? Okay, Miss Isbell, start over. right, new them in order, Miss Isbell. Okay, J is first. J is at 5, -2, right? Right? Y'all agree? K prime is at 6, +3, right? What am I doing wrong? Okay. Sorry, they keep me. No. J is right here, right? 7, -1. Okay, right? Thank you guys. Y'all, I haven't finished my cup of coffee yet. K is at, and that's just my traffic excuse. That would be at 6, +3, right? Okay. I can't see on my y'all. Y'all don't even know what kind of glare I'm dealing with. That's just another traffic excuse. And then L. There's L, right? 5, -2, right? Okay. Now Mrs. Will got it right. So, question. Like I said, there wasn't a fancy trick, but is there something you noticed? The Y stayed the same. Okay? So, if you have a vertical line that you're reflecting over, your Y's stay the same. So, you might want to write that as a hint. Y's stay the same if it's a vertical line. Okay? So, X equals the number means it's reflecting over a vertical line. And you're going to have to count your spaces. But your Y's should stay the same if it's a vertical line. Let's look down at number 7. This time we're reflecting over Y equals 2. And what kind of line is Y equals 2? Horizontal. So what do you think is going to happen here? The X's will probably be the same. So let's graph it. We got a parallelogram. Yeah, my screen's terrible. Maybe my new screen will be better. It's got to be, right? It's 12 years newer. This dinosaur I'm over here working on. Hey, but it's working, so I'm not complaining. All right, let me graph the original parallelogram. So y'all look up sporadically and make sure I'm doing it correctly, because apparently I'm crazy. 2, 3, and then 6, 1. Move that E down. And then F. Oh, that's ugly. So your parallelogram should look something like mine, except I didn't draw straight lines. All right, we said that we're reflecting it in Y equals 2, which is the horizontal line, right? Where is Y equals 2? It crosses what axis? The Y axis. At what number? 2. So I'm going to draw that line. And then what do I need to do to graph? How do I graph my new image? Yeah. Count spaces to my green line, which is Y equals 2. So E is 1 space, so I go up 1 for E prime. I don't want green, I want red. F is... How many spaces is that? I think so. So I'm going to go 5 the other direction. D is how many spaces? Well, D is 2. Yeah, I'll get there. So there's D prime. And then C is 6, you say? 1, 2, 3, 4, 5, 6. Top row, right? All right. Then there's my new one. So if I were to fold it, my paper, where that green line is, y'all see how they match up? See that? And then let's see if Miss Isabel can write the correct ordered pairs. Now, are my Y's staying the same? No. My X's are staying the same, aren't they? Yeah. So we had a horizontal line, so our X's should be the same. So C prime is the point -4, +8. Y'all agree? Y'all agree? D prime is -2, +4. Do y'all agree with that? E prime is the point 6,3. Do y'all agree with that? And F prime is the point 4,7. I'll go with that. Any questions about a horizontal line? Okay. The last kinds of examples get a little bit more complicated. Okay? Let's go ahead and graph that triangle, please. And then we'll talk about that reflection. So please go ahead and graph the triangle for me. So graph your triangle and look up and see if your triangle looks like my triangle. Give me a thumbs up if you got it. All right. All right, let's see if we remember back to Algebra 1. Y equals X. Slope-intercept form, right? Right? Remember y equals mx plus b? Right? So if I just have the equation y equals x, what's the y-intercept? 0. Right? What's the slope? 1/1. Right? Right? So your line will be at, starting at 0, 0, and then you're going to go up 1 to the right 1, up 1 to the right 1, and you're going to do that forever. So you're basically going to have a positive slope and go corner to corner through the origin. So you can use your ruler and make sure you go from corner to corner and go through the origin. And, ooh, I'm crooked. It's hard for me to do it on the screen. Corner to corner, there's your line of reflection. Okay, so it's a diagonal line. You cannot count spaces. So if you're trying to count spaces here, you're going to miss it. Okay, because looky here. What do you do there? You know what I'm saying? It's not going to be just right there. Okay, so we can't count spaces from a diagonal line. You can do that for a horizontal and a vertical line, but not diagonal. So there's a trick to this. If it's y equals positive x that you're reflecting across, you're going to change your x and y value. You're going to swap x's and y's. Highlight that and write that. If you're reflecting across the line y equals x, you're going to take your coordinates and you're going to swap your x and y. So mathematically super easy. So for x, we have the point -5, -2. So for x prime, I'm going to switch them. Okay? So the x becomes the y and the y becomes the x. So x prime will be -2, -5. Not changing any signs. I'm just swapping the order, x and y. Okay? So y prime. Y is -3, 4. What do you think y prime will be? 4, -3. You just swap the order. So z is negative 1, 1. What do you think z prime will be? 1, negative 1. So if you're reflecting in the line y equals x, all you do is you swap your x and y. Okay? And then you can go graph that triangle. So left 2, down 5. There's y prime. X prime. Y prime. And z prime. Is it? Now, ironically, we might have got z prime right, but we probably would have struggled with the rest of them. Okay, so you cannot count spaces if you have a diagonal line. If you have a diagonal line, then you need to memorize it. So if it's a y equals positive x, you swap x and y. That's it. So it is easy mathematically. You just got to memorize what to do. Okay? So let's see one more example of the last possible scenario. And let's skip down to number 11, please. We're almost done. This is my last example for the notes today. All right. This one says we're reflecting in what line? Y equals negative x. So let's go ahead and graph that original square, please. Go ahead and graph the square. Graph and make sure you label your points when you graph it. And when you draw your little square, look up at me and give me a thumbs up so I know that we're at the same place. Good. All right, how is the line y equals negative x different from the line y equals positive x? It's a negative slope, right? So this one goes through the origin, and it goes down from left to right. So that means the slope is negative 1 over 1. So I'm going from the corner, the opposite corners, down diagonally from left to right. Does that make sense? So if you just take your ruler and draw a line that goes from corner to corner and through the origin, there's your line. There's your line of reflection. Okay. So, as you can probably guess, there is a mathematical trick for the new images ordered pairs, just like there was for y equals positive x. So remember, for positive x, we just swap the x and y. When it's negative x, we're going to swap x and y and change both signs. So write that down. Swap x and y and change both signs. So if it's y equals negative x, we're going to swap x and y and change both of their signs. So I'm going to do the ordered pairs first, and then I'm going to graph last. So A is negative 1, 3. So I'm going to swap the order and change the signs. So what do you think A prime's coordinates are going to be? Good. Negative 3, positive 1. Y'all see how I got that? Anybody not see how I got it? If I just swap it, it's 3, negative 1, and then I change their signs. So B originally is the point 0, 6. So I swap the order and change the signs, and what do you think B prime's going to be? Yeah, 0 don't have a sign. It says 0. Okay? So C prime. C is 3, 5. What do you think C prime is? Good. Swap them and change both signs. And then D is 2, 2. What do you think D prime is going to be? -2, -2. So any questions about that? So y equals x, you just swap. Y equals -x, you swap and change both signs. So it's really not too bad to remember. And then lastly, we just graph them. So 3 of 1 is A prime. -0, B prime. C prime. D prime. So we should end up with another cute little square. And it should look, when you finish it, if I fold it along that diagonal line, A and A prime match up, B and B prime match up, and then all of them, okay? That's one way you can check it. So if it don't look like after you graph it, then maybe you made a mistake somewhere, or maybe you just misgraphed it. All right, any questions on any of the reflections that we've seen today? All right, that is the end of today's lesson.